So welcome to my YouTube channel. Today we are going to solve this problem, find all k-distance indices in an array. So the problem description is you are given a zero indexed integer array nums and two integers key and k. A k-distant index is an index I of nums for which there exists at least one index j such that the mod of I minus j less than or equal to k and nums of j is equal to k. Return a list of all k distant indices sorted in increasing order. So the problem is about here we give three input parameters, which is a nums array and the key element and the k element. So we have to find the jth element by this condition. The nums of j is equal to key. If and they also say at least one index must be present in this nums array. So if the key element is 5, so we have to traverse the nums array to find whether the key element is present or not. So after finding this, which is a jth element, so from the jth element we have to uh, as the k distant index from the jth element, we have to find the I element which we have to satisfy the condition I minus j uh, less than or equal to k, which is absolutely the ranges from j minus k to j plus k. The answer will be lies in. So here are the test cases. We can see that the nums array is this is a nums array and the key element is 9. So in the nums array the ninth element is present in the second index and the fifth index and k is equal to 1. So here we can check that the jth element will be 2 and 5. So we need to find the k distance for the second index. For the second index, the I range will be from one index to third index because the kth element is 1. So we need to find j minus k to j plus k, which is 1 to 3. So we need to find for these elements, we have to check. And again for this element, we need to check from j minus k to j plus k. So this is another example. We can go through that. And the length and we can also see the constraints, which is the nums length will be 1000, which is 10 power 3. Here it is a easy problem, so we can use the brute force approach also, which is we can use big O of n square. So there will be no TLU because we have to find the operations less than 10 power 8 operations per second. So we can use the brute force approach also, and we can also use the optimal approach. So here we can see. So in this problem there will be three parameters: the nums array and the key element to find the matching value, that is j, and the k element to find the k distant from j. Okay. So the brute force approach is very easy. We need to uh, first we need to declare a for loop which is I is equal to 0 to n, and another for loop which is a nested for loop which is j is equal to 0 to n, and we have to use the if condition to check I minus j less than or equal to k, and the nums of j is equal to key we have to check. So and if it satisfies, we can add the index and break. Otherwise we can continue until the end of the row. Why we have to break means because there will be a duplicate element also in this array. There will be a collision of elements which we can I will teach you later. So the optimal approach is very easy. First we need to divide this problem into a chunk of problems. First we need to find the jth element. To find the jth element, we need to traverse the array of nums of j is equal to key to simple. So next we need to find the ith element. So the ith element is lies between j minus k to j plus k. So as you can see, it is very easy. So we can, if the jth element is 6 means, if the k element is 2 means, we can simply calculate this and also this, so that we can so this is an range, but here in this case we cannot, this approach will be give the error because there are two edge cases is present in this problem. First is here in our problem we can take k is equal to 1 and k is equal to 9 as shown in the test cases. So in this array the jth element is present in here, which is second index, and jth element is here present in fifth index. So in our case the before approach will be work, but if this is a 9, if we assume this is a 9, so this is a jth element also, which is 3. So we just talk about the ith element is present between j minus k to j plus k. So here for the j is equal to 2th index, the answer will be lies here. For j is equal to 3, the answer will be lies here. So there will be a duplication of elements. So we need to avoid this duplication of elements. In order to do that, this is one edge case, and another edge case is if the j plus, if this is an 9th element, so this will be our j. So it will go out of bound error. So we need to, so this is a second edge case. So we need to handle this two edge cases. So first we need to find the range. So the range will be start from L to R. So initially we set R is to 0 because first we doesn't have any answer. So we just set this R is to 0. First we after finding the jth element, we need to calculate L and R, where L is equal to, we need to find the maximum as R and j minus k, in order to avoid the first edge case, which is a duplication of elements, because by finding the, okay, first I will explain the R computation. To find the R, we have to find the minimum of j plus k and n minus 1, which is the length of this array. To find this, to avoid the second edge case, which is out of bound, if we find the rth element, we can if we find the ending of the first index, we can't override as, because as you can see, in our case this is a jth element and we assume this is a jth element, so the R will be ended in here. So after finding the maximum of this element, so the L will be starts from here, so there will be no duplication of elements in this problem. By just doing that, we can overcome these two edge cases. After calculating R, we have to traverse from L to R, and we have to add the index to the answer array. As simple as that. So this is our optimal approach. First we need to traverse the array using the for loop and check for nums j is equal to key. After that we need to calculate a L and R and traverse from L to R and add I to the answer. So this is our answer to this problem. First we need to, this is the answer in Java. First I initialize the list and array list as from the Java library, and we set R is to 0 and we find the size, which is numbers.length, because we can't because it is very easy to by this declaration, and we need to traverse this array I to size, and we need to find the nums of I is equal to the key, and by finding that we have to calculate the L. by as from the board we can blackboard we can see that we have to calculate a max of r comma I minus k, and r is equal to minimum of size minus 1, which is length of this array, and I plus k, and we need to add a plus 1 because as the array is always start from 0, we need to add plus 1. So we need to traverse from L to R to add the jth element to the index, and we need to return this array list. So this is my optimal approach.